Hello, Tuesday the 14th. It seems that the rest of the problems of this section deals with making a theory for the L function of one specific elliptic curve. So let's get on with it. We need to find an expression for the Fourier transform of G. We must change variables, a linear and constant. That's not right. We must call this Z instead of oops, we can't put it out like that. When we make such a change of variable, the integral is the determinant of m, but then this is wrong. It's the determinant of m. This is like a dz1 wedge, etc. up to dzn, the wedge product. Now we need to put we need to put m over to operate on y instead. So let's just do it a z dot y in 2D to see what it gives. So it's a1 1 y1 a1 2 y2 a2 1 y1 plus a2 2 y2. So it's the first row, second row, this should be z. I'm just a little unconcentrated these days, it appears. And then we shall have those with z1 taken out. It's a1 1 y1. Is that z1? That seems wrong. No, it's a2 1 y2. There we go. So it's the transpose of A times operating on Y dot Z. To have some motivation for what we are doing, maybe we should start applying the no, that's making stuff more complicated. because if we sum this, then we need to know what we sum it over to be able to reduce this guy. So I think we should start here by finding the points of the dual lattice, and it's defined this way. So the generators are obviously that x dot y for all x in L are the distinct unit vectors, and since the the x values, the lattice here is generated by a matrix M, like this, which is invertible, then we can solve it. So it's just by applying M here and then finding the different. So the solution to M dot y equals the unit matrix are the dual, form the dual basis, or the basis of the dual lattice. I'll call it a dual basis. And this part seems really trivial, because when we have the solutions to this equation, all the multiply lie in here, and the other thing as well, if there is a solution here. Oh, I see, just finishing the first problem, that this guy is what they call M star. Actually, I think I've done this before and found that we had to transpose M and then invert it. And that's not what I get here. I just get y is the inverse of M, and I think that's wrong. So we'll just do the same job here. So this gives so we have to find a vector. Yeah, it's the same problem. We have to find a vector so that this dot product gives the unit vectors. Gives naught from all unit vectors except one. So it will come out to give the same, really. So this was not quite right. So what we get by applying that is that the basis is called L mark, yes. And it's still M. Transverse. It was the other way around, but that they commute. And that means that if we sum, then we sum for y and this is what we sum over g hat of y, so that we have that here. And this was just m star. There's a mistake here, because we have to, then I have to do it twice. What I thought we would get is simply some f hat x element of L, but that's not the point. So I've been quite confused at some place. I don't know which. So it's a little break while I read it through and see what I've got. Having finished my coffee, I suddenly realized that it's the Fourier transform of f in both formulas. So this is all wrong. This is simply f hat of y and then we can sum over x element in integers. Then y is m star times x. And if we instead say we let z go over m, z to nth, then x equals m to minus first z. That really doesn't make any sense, does it? Because this is the inverse, and so is this. So I want to have a sum. We start with a sum over L mark, yeah, and I want to have a but then this so this is a sum over z to n. So we can use Poisson's summation formula. If we can find a guy whose Fourier transform is this, and indeed we can, we just put this on the other side. So that equals the determinant of m g hat of y, and g was defined as f of m of x Now, what was the point? We first have to use Poisson's addition formula, summation formula, and then we can insert what g is. And this is just the sum over the lattice. All right, that was it. So once again, I suffered from not reading the problem with sufficient scrutiny. I thought it was G entering here. That was what I had read. I'm not sure I wouldn't have got into trouble anyway, but that's it.